All right, in this experiment, we are going to control the pitch of a sound generated by the Arduino by using a photoresistor. But a photoresistor is kind of like a potentiometer because you can vary the resistance of it. And unlike a potentiometer where you turn a knob to vary a resistance, you vary the resistance by changing the amount of light that hits the surface of the photoresistor. Okay, so to get started with this project, we are going to use our speaker, the photoresistor, and some various jumper wires, and some of our fixed resistors also. We're going to start the project by removing all of the components from the solderless breadboard and the Arduino. So we're starting over from scratch. And then we want to get the 100 ohm resistor, and that's the one that is colored brown, black, and brown. And we're going to put that into digital pin number 9. And we will stick that into row 14. I'll put it into J14. Like so. Okay, and then we will connect our speaker, and we'll put the black wire into the blue line ground rail, and we'll put the red wire into I14. And so you can see we have this resistor here. This resistor is limiting the electricity that's going through the speaker because we don't want to burn the speaker out. Okay, so the next thing we want to do is connect the photoresistor, and one lead is going to go into J20. So let's find J20. And the other one is going to go into our positive voltage rail, which is the red colored rail. And it doesn't matter, unlike an LED where you have to be concerned about the direction that you put it into the solderless breadboard because there's polarity in it, a photoresistor doesn't have any polarity, so that it doesn't matter which lead goes into which hole. Just put one lead into the red rail and one into J20. Okay, and now we're going to connect this photoresistor to the Arduino. So we'll take a jumper cable and we'll put one end of the jumper wire into row 20, and the other one we're going to put into analog pin 0. That's marked A0. And that is, by plugging it in there, you're letting the Arduino measure the current going through the resistor. And the current is going to change depending on how much resistance is in the circuit. And the amount of resistance going through it is dependent on how much light is hitting it. Then we're going to put in the 4.7 kilo ohm resistor, and that's the one that's colored yellow, purple, and red. And so we're going to put that on between H20. We just want it somewhere in row 20, and the blue lined ground rail. Okay, and then we're going to connect a jumper wire between the blue line ground rail and ground on the Arduino, so that we are going to activate that entire blue lined rail there, and we can plug it into, there's a few different ground pins in the Arduino. You can already hear that it's making some sound, but we're not done with it yet. What I'm going to do just to keep things quiet is I'm going to unplug the ground wire on the speaker. We'll get back to that in a minute. Okay, so then we want to connect another jumper between the red lined ground rail on the solderless breadboard and 5-volt pin on the Arduino so that we can supply power to the entire 5-volt rail. Okay, so now that we've wired up the circuit, let's load up the tone pitch follower sketch from the Arduino development environment. So once again, we go to File, Examples, go to Digital, and then go down to Tone Pitch Follower, load it up by hitting the Upload button. Remember, I pulled the ground wire of the speaker out of the solderless breadboard. I'm going to plug that back in. Okay, so now we have this photoresistor. Let's see what happens if we change the light by putting my finger over it. And so you can vary the sound. And it's almost like a musical instrument. You can almost cancel the sound out completely by putting your finger over it and covering it. It's a very low tone. And the more light that hits it, the higher the tone. And if I were to shine a bright light on that, I could get it even higher. So that's a great example of the input is the photoresistor, the processing is done by the Arduino, and then the output is a speaker. So let me unplug this again. So you can see that I've shown you several different output and inputs. In the next video, I'm going to talk about how you might be able to mix all of these things up and do other kinds of input processing, outputting experiments with the Arduino.